Anybody who would like to help us with number 4? So what is the shape in number 4 and how do you find its perimeter and area? Juan.
So the number 4 gets a trapezoid.
Okay.
And since where the right angle is, since it's 4 centimeters, you just move the triangle to the side so it'd be 4 by 7.
That's nice. So you're trying to say you split this one also?
Yeah.
Is that what you did? Okay. So if this is 4, this is 4. Did you say 4 by 7? So what do you mean 4 by 7? Where do I put the 7?
Oh, each side is 3.
Each side is 3. Okay. So the bottom will have a total of 10. Okay. And then?
What I did is I just flipped the triangle to the side and then took it away. So it'd make each side 7 and it would be a rectangle.
Oh, you turned it into a rectangle.
Yeah.
So you completed this portion over here. Is that what you're doing? Okay, so this is also 4, right? And this is 3. So then you turn it into a rectangle that is a 7 by 4 rectangle. Yeah. Okay. So then what's the total area that you got?
28.
28. So, okay. So it turned out to be a rectangle which has 7 on top and 4 for the height. So then the area is equal to 28. Yeah. Very good. Okay. Who got the answer in a different way? Who got the answer in a different way? Anybody? Does anybody know? I just want to say, if you guys don't know the formula, so follow what Juan did. He came up with another shape, right, from the original trapezoid that he's more familiar with, which is basically flipping the triangle, turning it into a rectangle. Okay, that's good. Another method. Does anybody know the formula for a trapezoid? Nope? Okay. So I'm pretty sure it was also mentioned in middle school, but if not, it's okay. So for the area of a trapezoid, it's also equal to height divided by 2, okay, times the quantity base 1 plus base 2. You knew that? Yeah, so now it's all coming back like, oh, I know that. Okay, that's fine. So let me put the over 2 right there. Okay, now looks familiar, correct? Yeah. All right, let's figure the parts out. The height is this one, that's your H. The B1 and the B2 can be interchanged. It doesn't actually matter. I usually just put the base one underneath, okay? And then that's it, right? You're ready to plug them in. So let's see if we also get Juan's 28. So area is equal to, the height is 4, base 1 is 10, base 2 is 4, and then divide by 2. Okay, so what is 10 plus 4? 14. And then 14, what's 14 divided by 2? 7. And then you times it back to the 4 again. Does that make sense? Okay, so 4, and then that's 14 divided by 2. I don't want to do 14 times 4 in my head, so I went like, oh, let me do this first to make the number smaller. So then this turns into a 7. So 7 times 4, we're also getting Juan's 28. So whether you use the original trapezoid or you switch it to a rectangle, same. Yep? Okay, quick question. I didn't show the part for the perimeter, but for the perimeter, all you need to do is add 5 plus 4 plus 5 plus 10. When you're finding the perimeter, you don't count what's inside, okay? Because imagine you're just fencing around it. So if you put a fence around that, that's what we mean by perimeter. Okay. Other questions? No? All right. Okay, so go ahead, give yourself maybe like a minute more to turn that in. If you're done, we're going to move on to the next thing. Okay. Now, for those who are new also, the best way to catch up, although you will be excused from the days you were not here for, if you see this folder, teacher slides and recorded notes, I have everything from week 1, okay? So if you want to figure out, oh, what have they finished already, so I can catch up on that, everything is in here. I just started recording though recently, yeah, because of the switching in and out of students. So there's only like 1 or 2 recorded notes on distance formula, and then I recorded period 1 earlier with the new lesson. Okay, so click on week 3 geometry, guys. Week 3 geometry, you're gonna see that PDF over there. The next lesson will be still on finding areas and perimeters, but we are now gonna place those shapes on the Cartesian plane. So you will see them on the XY axis. Okay, I think you can find it on slide. Stop where you see the triangle. The slide with the triangle on the graph. Okay, and if you find that page, go ahead and start drawing that. Still loading. Okay, keep going. I have some notes there for you as well. There you go. So you can see some formulas there if you've forgotten it. Some of you started on this yesterday while the others are doing iReady, where you find the perimeter of a composite figure. So Juan's technique here will be, will be useful. You can either chop them off into smaller shapes. I don't know if you had a hard time working on this yesterday, but if you want to try this one later on, you can. Okay, I have to annotate. Okay, you can chop them off into smaller shapes. For example, there you go. If the whole thing is 18 and you take away this portion, that's going to be a 9, and this is also going to be a 9. So when you find the let's say perimeter or area, make sure that you figure out some of the unknown quantities. If this is 15 and the one at the bottom is 7, so 15 minus 7, that's going to be equal to 8. So once you know this is 8, you can find the perimeter around it. If you want to find the area, okay, so you have to get the area of 2 smaller shapes, right? Okay, I know some of you did that yesterday. Okay, but let's move on. Oh, no. Okay, so I'm moving on to the next slide where our lesson is at. Some of you did this on the consumable yesterday, right? Okay, we're gonna go back to that. I just want to be able to move us on. Okay, where's the page I'm looking for? Okay, this is where we're gonna start copying our notes. Okay, here we go. All right, so let's review first. What do we have here? I'm pretty sure is it showing on your computer? Yeah, okay, there you go. It's just loading. It's a little bit slow. Okay. All right, so what do we have here? We have here an example of a polygon, which we talked about previously. All right. Okay, so what are the parts of a polygon? So you can see here, each corner is called a vertex. All right, there you go. And then you also have the sides. I think it's better to just copy us from their screen. Okay, so in this case, count the number of sides and tell me what kind of polygon do you guys see?
I see a pentagon.
You see a pentagon. It has 5 sides, correct? Nadia, do me a favor, please. Save your battery for later. Okay, so in a pentagon, there are 5 sides. There are also 5 angles. There are also 5 vertices. Later on, when we do the consumable, you will be asked to identify what kind of polygon is it based on the number of sides. And then we will be asked whether it's a concave or a convex polygon. Okay, so if you scroll down further, you will have there the definitions of convex and concave polygons. I want you to compare what's happening between the 2 shapes, and in your own words, tell us When is a polygon convex? When is a polygon concave? So look at what's happening. So when does it become convex? When does it become concave? If you see the shape outlined at the back, like in black ink, that was the original shape. So you have 1, 2, 3, 4 sides. It was originally a quadrilateral. And then what did they do? They drew lines on each side, yeah? So the red lines, those are the lines that were drawn over each of the 4 sides. So what happened? What happens when you draw the lines? Is there any red line that pierces through the shape or no? No. Okay, but in the second figure, see what happened there? There are 1, 2, 3, 4, 5 sides also. Did I count that one? 1, 2, 3, 4, 5, 6. So it's a hexagon. Okay, so they chose this side and extended it, drew a line over it. Now what happened? Did the red line pass through the interior of the polygon? Yes. Can you find another line that behaves in the same way? Can you find another side such that when you extend it, it will also pierce through the polygon? And come here to the front and draw that line. Anybody? Yes, please, Tony. To draw another line such that it goes through the interior. That's great. And it passes through the interior big time. Look at that long segment that goes through the interior of the polygon. Okay, so if you can find at least one line such that when you draw it to extend a side, it passes through the interior of the polygon, then the polygon is concave. Okay, I want somebody to come to the board and draw an example, another example of a concave shape. Anybody? So make one up and draw it here. Take off your earphone, buddy. Save your battery for later. Anyone? Come on now. Draw it here. Just make an example. Aiden, let's go. So draw any shape. It's going to be concave. All right. Okay, Aiden, stay there. Now show that it's concave by drawing at least one line that pierces through the interior. Use another color. There you go. Okay, and one ruins it for all. Once you draw one line that pierces through the interior, then it is already a concave polygon. Okay, the first 6 questions on page 20 to 21 will be similar to that. So can I give you about 3 minutes? Go get your workbook and go to page 20. Ethan and Fernando, do you have a workbook? No? Okay. Do me a favor. I don't have an extra. Do you know the textbook? Can you go get one? But not get a book, a hardbound book. The hardcover. You have that? Yes? No? You don't have it yet? Okay. So you're gonna, because you already went there yesterday. So can you go there, bring this back, and go to Miss Alcantara, that first, Arciaga class, and the hardbound book, and that's consumable. Hardcover and Word. Thank you, boys. All right, give yourself 3 minutes, guys. Page 20, did I memorize the page correct? Okay, so, yeah, that's the reason why I made you leave that here, so you don't copy a lot of figures. They're already printed out for you. Go ahead and answer number 1 through 4, and then we'll start on the graphs just a little bit. You left it at home? Which one did you guys do? Okay, don't worry, I have a copy digital in Schoology, so give me 1 second. Yes, my dear? Are we doing the ones that we did yesterday? For now, just focus on this one. Let me think about that. Give me 1 quick second. I don't want to, okay. Okay, Alex, if you refresh your browser, yeah, just do 1 through 4 for now. We're gonna do the next lesson to show the next section. Okay, Alex, refresh your browser. You should see something like skills practice, polygons, perimeter, and area with a blue puzzle thing. Do you see it now? Yeah? Okay. So since you don't have your workbook, that's your copy. And then next week though, you have to like enter your answers online. So that's why, yes. Yes, dear. Yes.
Are we just doing? Go to what's it called, the teacher slides.
Okay, if you guys are finished writing down your answers, refresh your browser and go to week 3 folder. You will see something like 1.4 skills practice, polygons, perimeter, and area. So you're showing your work on your workbook, but to check for accuracy, okay, to check whether your answers are right or wrong, we are going to place them. The deadline is next week, September 5th, when we come back. We are going to enter our answers online, okay? And then you also have 2 attempts. If you get them wrong, you redo them. So at least you don't have to copy a lot of pictures on your notebook because everything is on the
Wait, what's the name of the thing we have to follow?
It's a blue puzzle thing called 1.4. Skills practice, polygons, perimeter. Yeah. Okay. All right, but you can't do all of those 22 points yet because you have to move on to the next lesson and then do the one with the graphs. Okay? All right, can I give you 1 more minute and then I'm going to starting again with the second portion of the lesson, and then after that you can continue working on your workbook. Okay.
So we just do 1 through 4 on page 1?
For right now, yes. And then we'll do a quick lesson, and then after that you're going to go back to those pages. Okay, so let's move on. As you can see on the board, it's the same shape. It's a triangle, same as the warm-up. The only thing different now is they graph the triangle on the Cartesian plane. So what we're going to do is find the perimeter. Okay, so what do we need to find the perimeter of that shape? What do we need to find the perimeter of that shape? Anyone? What information do we need? The sides, very good. How many sides are there, Nico? There's 3. Okay, so first, let's find side AC. Did you get one?
They said she was taking her lunch, so we gotta come back later. Yeah.
Okay, sorry about that, boys. But thank you for trying. Okay, so first let's find AC. Next is let's find BC. And then after that, let's find AB. So Nico said there are 3 sides. Then let's look for all those 3. How do I find AC? How do I find AC? AC is the base. Count the number of boxes. Okay, you're taking an AP course later on, and you'll be like, okay, so my AC is 1, 2, 3, 4, 5. That's not enough. You're gonna show more work. Okay, 2, 3, 4, 5. Okay, I get you. That's 5. But then, in what way can you write that? Where did that come from? Yes, Catherine.
Well, even with the toilet, she said, like, 6 outside
Good. Use the coordinates and subtract them. There are two sets of coordinates, x and y. So which one should we use?
Well, both for well, this one we're doing CB or AC?
Let's find AC first.
Okay, so AC.
Okay, so is that 5 then? Then it's not 5. So how high is the triangle? So 1, 2, 3, 4, 5, 6. So that's the 6th one. Okay. And then keep going, Catherine.
So seeing as the x coordinate is the same for both of them, that means they're on the same. The x coordinate is not going to change, but that's not the difference between them. The difference between them is the y coordinate. So you're going to subtract the y coordinate.
Okay, so let's subtract the y coordinates. Let's start with that because A was first. 3
No.
take away.
Yeah.
And then what's the next one?
-3.
-3. Okay, so what happens when you have two negatives? Positive. And that's how we get the 6. And yes, you can get that just by counting the number of boxes. But if you're asked to show your work, you're not going to say, I counted the boxes. Am I making sense? Okay, next, BC. BC.
Do the same thing, but on the x end.
Very good. Do the same thing. That's the one we're expecting to be 5, right? So Quincy, finish it up.
Oh, so we do -2.
So absolute value of?
Well, the absolute value of -2 take away 3 is 5.
5. Very good. So the absolute value of -5 would be 5. Awesome. Okay. Can we do the same thing to AB?
No.
Because it's diagonal now. You
A-
can't
A
just go
squared
count the
plus B
boxes.
squared.
Say that one more time.
A squared plus B squared.
Very good. We're going to do either A squared plus B squared is equal to AB squared, right? Or we can also do the distance formula. But I think you're more comfortable with the Pythagorean theorem. So let's do that. So AB squared. Now, instead of A squared, try to kind of transition now into how you write them in geometry. Yeah, so your A will come from, it's either BC squared, however you want to write them. It doesn't matter which comes first. So now let's substitute. BC is 5, AC is 6, and we're trying to find AB squared. 25 plus 36 becomes 1. Okay, so this is AB squared. But in order to find just AB,
You have to do the square root.
you get the square root of both sides. So that will cancel the radical and the 2. Okay, if you're asked to leave it in simplest radical form, that will be the answer. But since we want to get the perimeter, let's go ahead and help me change that to a decimal. We're expecting a number lower than what?
Lower than
What's the next perfect square after 61?
8.64.
64.
Lower.
7.8.
Good. So KDB got
7.8.
7.8. So that's a good one. It's lower than 8, right? Okay, so even though you don't have a calculator, you can kind of approximate. Turn to the next, turn to the next perfect square. Say, oh, 8 times 8 is 64. So I'm expecting a number lower than 8. Well, now it's just a matter of, do I put 7.1 or do I put 7.8 or 7.9, right? Well, it depends on how close it is to the perfect square. Okay, so perimeter now equals, add them up, 6 plus the 5, so 6 plus 5 plus 7.8. How much is that altogether? 18.8. Okay, so 18.8 units if there is no other unit use. Now, what if, let me just add another extra. What if they ask for the area? Do we need to do all that work for area? No. What two numbers do we just need to find the area?
5 and 6.
Good. So what's the area of the triangle? 30. Divide by 2, remember?
Yeah.
Base times height divided by 2.
15.
15. Okay. All right. Quick question about this. So the simplest case is when you already see a right angle at the corner, right? And you can do Pythagorean theorem. If it wasn't a right triangle, you can't do Pythagorean theorem to find the third side. Okay. We'll look at those cases next time. Okay, we're gonna move on to the next slide, one more, and then I'm gonna ask you to go back to your workbook. Scroll down to the next page. What kind of triangle do you see? It looks like a scalene triangle. Yeah, there are no two sides that are equal. Somebody thought earlier it's isosceles, having DE and FG congruent, but I don't think they're congruent. Okay, so it's a scalene now. Find the area. So let's write down the area for a triangle. It's base times height divided by 2. Okay, in this shape, what is your base? What could be the base? FE. Is there any height already?
Yeah.
We can figure it out. Can somebody come to the board and draw the height?
It's D from the base.
It's D from the middle going to the base. Perfect. So make a straight line going down. All right. Okay. So let's call that DA. There you go. What are the coordinates of A?
Negative 3, 1.
1, negative 3. There you go. Okay, so let's call that A. The height is DA. Okay. All over 2. Okay, so now help me. Find FE by showing your absolute value formula. And then find DA by also doing your absolute value formula. And then we're going to plug it in. Okay, give yourself 1 minute. Use absolute value. Pair up the numbers. If you remember what Catherine said earlier, it's along the X, so don't use the Y values if they're the same. Okay. So what two numbers do we pair up for FE?
Negative 4, take away 4.
Negative 4, take away 4. Final answer?
8.
8. What do we pair up for DA? Okay, so 3, take away negative 3. Final answer? 6. Okay, so now we're ready to find the area. So area equals FE is 8. DA is 6. We divide by 2. Final answer? 24. And then we put square units for area. Okay. All right. So go back to page 20. Try to work on some of those crafts. Let me see if I can help you with that if you don't have a workbook. Maybe I can. Okay, if you don't have a workbook, go to week 3 folder. Week 3 folder. Go back and then week 3 online, yeah. And then the blue one. There. So that's the same page from the workbook. The problem is you just have to you don't have something to write, right? You don't have a workbook. You just do it out of the notebook. I have some papers there. Okay?